So we're going to get straight into it. If you joined us last week, we spoke about 3 important steps that we need to remember when we simplify. If you didn't, I'm just going to recap them very quickly. Alrighty, so 3 steps. Step number 1 is you want to identify each term in your expression. If you do that, it allows you to simplify the expression a whole lot easier. Second thing we want to do is simplify each term, because what that means is once each term is simplified, all I need to do is move on to step 3, which is collecting my like terms, and we know how to do that. All right, so we're going to start with the first example here. I'm just going to make this bigger so we can all see. We've got 5x squared plus 3x plus x squared. Now, the first 2 steps actually we really don't need to stress too much about, but we're going to do them anyway so that we get into the habit. So identify my terms. Remember, a plus and a minus sign separates your terms. So I've got 3 terms in this expression. None of these terms can be simplified. So if I scroll back up here, step 2, I can't simplify the individual terms. They're as simple as they can get. So I can go straight on to step 3 and find my like terms. Now, like terms have the same variable and exponent. So I've got x squared terms here, and I've got an x term. So I've got 2 groups of terms that I'm actually working with. Once I know what my like terms are, I can simplify. So now I'm going to add 5x squared plus x squared is 6x squared. And then we've just got the plus 3x. He's not added to anything because he doesn't have any like terms with him. So it's just 6x squared plus 3x. Alrighty, so starting off nice and easy. Don't forget, if you want, you're welcome to put your answers in the chat as we go, but hopefully that first one wasn't too bad. Alrighty, so let's have a look at question 2. All right, so we've got 4x times the bracket minus 2x cubed. Now I've thrown in a little hard one here because you guys were doing so well last week. I thought I'd give you a bit of a challenge. But we're going to break it down. We're going to follow those 3 steps. So step 1, identify my terms. Now the only plus or minus sign I have is inside the bracket. So I don't need to actually stress about that. And so what I actually have is 1 term. That whole thing is 1 term. So we're going to break it down for ourselves. And you are always welcome to break down a term if you need to, so that you can see what operations are happening. This term is saying to me 4x times the bracket minus 2x cubed. Okay, you can break this down even further, particularly if you're not comfortable with exponents. And you can say, all right, well, if I've got a bracket cubed, I know that this means I'm multiplying the bracket 3 times. So I'm multiplying that exact same bracket 3 times. 3 times. And so if you want to expand that even more for yourself, you've got 4x times minus 2x cubed times minus 2x cubed times minus 2x cubed. So we've got a bit of multiplication that we need to do here, but because we understand what the exponent is telling me, and because I've broken down my term into everything that I'm multiplying, I can do it. Okay, so if you were with us last week, we spoke about a little trick that we can use, which is SNV. If you weren't, what this stands for, or what this allows us to do, is to make sure that we are multiplying correctly. So S stands for signs. So that's the first thing we'll do. We'll double check what the signs are. Then we'll move on to the numbers. And then we'll move on to the variables. And basically what this is once you've figured out what sign your product needs to be, you're done with the signs. You don't need to stress about it again. So if we have a look here, let's start with S. So signs is, I've got a positive, whoopsie days, oh, it's fine. Positive times a negative times a negative times a negative. So take 2 seconds, have a think about it, and then pop for me in the group. What do you think a positive times a negative times another negative times another negative is going to give us? Just what sign it's going to give us, a positive or a negative?
Let's go, my people. You guys are doing great. Yes. Yes, my people. I can see you. And remember to do corrections, okay? So remember you've written your answer and then teacher Sam will correct us and then we just have to mark ourselves.
Okay, guys, awesome. Well done. I'm seeing a lot of negatives. That's great. Just quickly, if you're confused, a positive times a negative is a negative. That negative times another negative gives us a positive. And that positive times the last negative gives us a negative. So my sign here is negative. Now I've dealt with the sign. I'm sorted. Done. Now I move on to the numbers. If I look at the numbers, I've got 4 times 2 times 2 times 2. So quickly on your calculator or quickly in your head, I want to know what 4 times 2 times 2 times 2 is. You can put it in the chat. If you're feeling brave and you want to raise a hand, you're welcome to. But otherwise, pop in the chat what you think 4 times 2 times 2 times 2 is.
Let's go, my people. And if you're not sure, teacher Sam is actually allowing us to check with our calculator, guys, which is great. So you can just have a calculator and you can check those numbers and if you got it wrong or right. Okay.
Okay, awesome. I'm seeing lots of 32s. That's great. If you're not using a calculator or if for whatever reason your teachers feel you shouldn't be using a calculator, that's okay. I'm very much pro calculator. But if you need to practice without, that's cool. If you need to do it without, you break it down. So start with what 4 times 2 is. 4 times 2 is 8. Then you'd have to times another 2. So 8 times 2 is 16. And then you have to times the last 2. So 16 times 2 is 32. And so now we get that our number is 32. Good. Well done, guys. Now we have to go on to these variables. Now we need to be careful here because we know that when we multiply variables, our exponent laws have to come into play. And if you've forgotten your exponent laws, I would strongly, strongly recommend that you guys go back and sort of just, sorry, my screen just decided it didn't want to be here anymore. That's okay. We're gonna bring it back up. So as I was saying, what we need to remember is that we need to apply our exponent laws. And we know that when we are multiplying with exponents, I add the exponents. So if you have a look here, there we go. Hopefully we're back. If you have a look, great. If we have a look here, I've got an x times an x cubed times an x cubed times an x cubed. So if you want to write it out, you can. X times x cubed times x cubed times x cubed. And the little question you can ask yourself is, in total, how many x's am I working with? I've got 1, I've got another 3. Oh gosh, that's 4. Then another 3 is 7, and then another 3 is 10. So when I multiply all of those together, I've got an x to the power 10. Alrighty. So your final answer there, I know my answer is very colorful, is negative 32x to the power 10. And it's only one term, so there's no like terms that I could add or subtract. That's it. So what we need to be careful of is even when we're working with algebraic expressions, there's lots of different things we need to remember. So we need to remember how to multiply negative numbers. I need to remember how to multiply exponents, etc., etc. So this is just an example of sort of bringing in a lot of different things that we need to remember to be able to do when we work with algebra. Alrighty. Okay, guys, cool. Well done. So let's have a look at the third question over here. I'm going to start you off and then I'm going to ask you to finish it for me. So we've got 2 times 4a minus 7a minus 4a plus 3a times 3. So the first step, remember, is to identify your terms. Now that minus sign over there and that plus sign over there are going to separate my terms. The negative sign inside the bracket, we don't stress about signs inside the bracket. So this is term 1, this is term 2, and this is term 3. Once I know what my terms are, I can go and simplify each term. So that might mean I need to multiply. Sometimes it means I need to divide, and only then will I simplify the whole expression. Right, so I'd like you to have a try of this one. You know where your terms are, so try and simplify the whole thing for me. And then if you've got an answer and you're feeling brave, you're welcome to raise your hand. or you can pop it in the chat so we can see what's happening.
Let's go, my people. You're allowed to talk to us, okay? KM, I see you saying you're a little bit confused, so you can either raise your hand so you can explain to Teacher Sam and I where you're getting confused, and Teacher Sam can help you. Okay, there we go. Thank you. Remember that there's a little box pop up on your device. If you can click on it, there we go.
Yeah, I saw it. Miss Whitehorn, I'm a bit confused. So, you know how in the old example where there was where you cubed a number,
Yeah.
and then so if you were to cube it, right, and then you do the method that you were using, wouldn't, if it was inside the box, wouldn't it have only cubed the x, not the coefficient?
Okay, so what we need to be careful of in this one is the cube is outside the bracket. So that cube actually applies to the whole bracket. So it needs to affect the x and it needs to affect the coefficient. Sorry, yeah, carry on.
I understand. In a way, it's just so you duplicate, you sort of did the brackets times the brackets, then the brackets again.
Sorry, I keep interrupting you. Yeah, as in?
So doesn't that mean it gets times by the variable, not the -2? Which is I'm a bit confused about.
Okay, so essentially what's happening here, and I'm just going to sort of separate this out and just look at that. What I have is the -2x cubed being cubed. Now, what that's saying is that everything inside the bracket is being affected by this exponent outside the bracket. So everything in the bracket must be multiplied 3 times, which is why when I expanded it over here, I've got 3 of the same bracket, because that's what my exponent is telling me to do. Because that exponent is outside the bracket, like I say, everything inside the bracket has to be affected by it. This isn't necessarily how you have to do it. You can apply the exponent laws that you've learned and sort of say, okay, well, if I've got -2x cubed to the power 3, I know that that should multiply to the 3 and it needs to multiply to the exponent that is with the -2, and you're welcome to do that. The reason I like expanding it is because it makes me aware of the signs that I'm working with. So what you need to remember is, even though this cubed over here only applies to the x, the cubed outside the bracket has to affect the whole bracket.
Okay.
Does that make a little bit more sense?
Yeah, I think I get it now. Yeah.
Okay, good. Well done. Good. Okay, guys, so let's go over to number 3. So we identified our terms. Now we need to simplify our terms. Now, there's actually 2 ways to simplify the first term. So I'm going to do it one way, and then I'm going to ask you if you maybe did it differently, and then we can see. So in the first term, we need to distribute. We need to multiply. So 2 times 4a is 8a, and 2 times -7a is -14a. Right, so that's that one done. The second term, we said we can't simplify because it's just -4a. But the third term, I've got 3a times 3. So 3a times 3 we know is +9a. And then all I need to do is add and subtract my like terms. So my like terms here are the a terms. Oh, they're all a terms. Getting ahead of myself. All of them are actually like terms with each other. So we can just go and add and subtract. So 8 minus 14a is -6a, -6a minus 4a is -10a, and then -10a plus 9a is just -a. So that should be your answer for question 3. All right, so if you didn't get that, just go and double check where you might have gone wrong. If you did it slightly differently, just because I'm seeing there's a lot of different answers here, what you could have done for term 1 is you could have seen that these 2 terms were actually like terms. So you are welcome, if there are like terms inside a bracket, You are welcome to simplify what's inside the bracket and then multiply, but you will end up with exactly the same answer. So either way is absolutely fine. Right, so just because I did see a couple different answers, can I just get a hands up or a thumbs up or a thumbs down if you, after this explanation, feel okay, or if we're not feeling so okay after that?
Well done, my people. Well done. And remember, you can always ask. So what I like about writing things down is that now is the chance where you look at your answer and teacher Sim's answer, and you can do the comparison and see if you do realize your mistake. If you don't realize your mistake, however, please do raise your hand and ask questions or put your questions on the chat, and I promise you, you're going to get the help. Okay.
Okay, cool, guys. Exactly that. And those of you with a thumbs up, thumbs down, if you have questions, exactly as Yolanda just said, you need to ask, please, please, please. Otherwise, I'm going to assume that we just need a little bit more practice, right? And 100%, some of these are going to be a little bit more challenging because they might not be something that we've done yet or that we're necessarily used to. But as I keep saying, if you can sort of do the 3 steps or try your best to do the 3 steps that I've shown you, simplifying algebraic expressions will become a little bit easier. But guys, with anything in maths, it's practice. Okay. And then, like I say, if you've got questions, if you're not feeling confident, just say where you're confused or what's going on. Alrighty, so let's have a look at question 4. Now, before you all start copying down questions, actually, no, we can do this because we're going to use SNV. So we've got this. Right, so question 4, there's a little bit going on, but we break it down. With anything in maths, don't try go full force, break it down for yourself. So in this case, I only have one term because I've just got the fraction. And when I look at this, it does look a little bit confusing, but I have a trick that I can use. I've got SNV, signs, numbers, variables. Alrighty, so that is where I start. For the signs part of this, I can see that there's a negative in front of the fraction. Now that isn't going to change because it's not like I've got a negative 35 divided by a negative 40. I've just got one negative. If I had a negative divided by a negative, we know we would end up with a positive. So my sign is actually sorted. I've got a negative there. So that sign's done. Cool. Once it's done, it's done. Don't care about it anymore. Now I'm going to move on to the numbers. So the numbers I'm concerned with are the 35 divided by 40. Now again, I'm very much pro calculator. And so you could just type this into your calculator and your calculator will give you a simplified answer. But if we need to be able to do this without a calculator, what you need to ask yourself is what is the biggest number that can divide into 35 and into 40? So in the chat for me, right, Lesejo has told us both can be divided by 7. Lesejo, double check, can 40 be, English. Can 40 be divided by 7 without a remainder? So that's what we want to check for ourselves. Can I divide the number into it and have no leftovers? Awesome. So I'm seeing some 5s there. Great. Both of them can be divided by 5. So that's what I need to go and do. If I divide 35 by 5 and 40 by 5, I'm going to end up with 7 over 8. So that is my number part of the fraction simplified. Okay. Well done, guys. Now we move on to the variables. Now I have got 3 different variables that I'm working with here. So we're just going to start with the first variable. We're going to start with x to the power 10 divided by x to the power 5. Now again, grade 8s, the beauty and the curse of exponents is that often there are lots of different ways to do the same thing. Okay, so if I have a look here, and I'm just going to do it on the side here, but x to the power 10 divided by x to the power 5. If you want to use your exponent laws tell you to subtract exponents. So x to the power 10 minus 5. That's absolutely fine. It gives you the correct answer. I personally never use the exponent laws when I divide. It's just something that doesn't work for me. I use cross cancelling. So I say, alrighty, well, if I've got 10 x's in my numerator and 5 in my denominator, I can cancel 5 at the bottom with 5 at the top, leaving me with x to the power 5. I get exactly the same answer. So however you choose to do it, that is up to you. What we need to remember though, is that my leftovers, or that x to the power 5 answer that I got, is sitting in the numerator. So it needs to stay in the numerator. It can't all of a sudden move to the denominator. Okay, so I want you to try and finish off simplifying the y's and the z's for me. And then you can put your answer straight into the chat, or you're welcome to raise a hand. But keep simplifying those variables so that we can get a final answer here. So you've still got the y's to simplify, and you've got the z's to simplify.
We can do this, my people. We are doing it. Well done, guys. I'm so proud of you.
Okay, grade 8 again, this is just an example of doing simplification, but also needing to remember exponent laws. And as you start to do these more and more, that's going to become really important, being able to combine the two concepts.
For those who are behind also, I think we have done exponents. So guys, you are more than welcome to look through the videos, and I'm sure you will get something about exponents. Okay, will be a good practice for you.
Yeah, so I did have a look. I'm pretty sure Yolanda's right that exponent, oh gosh, my English tonight. The exponent videos are all on the website. I did double check because I didn't want to do anything you hadn't done. So there should be exponent videos, so please have a look. All right, I'm seeing some wonderful answers here. Keep going, guys. Okay, now if we just have a look at the y's, you can do exactly the same thing as what you did with the x's. So you've got, I'm just gonna do it a little bit next to the x's. You've got y to the power 7 divided by y to the power 8. And what we need to be careful of is the fact that I've got more y's in my denominator than I do in my numerator. And so if you go and subtract, you're going to end up with a bit of an odd answer. You're going to end up with a -1. But we know from doing exponents that all that means is that my y is in the denominator. If you're going to go the cross-canceling route, which is why I like cross-canceling, I can see 7 y's in my numerator cancel with 7 y's in my denominator, leaving me with 1. And the reason I like cross-canceling is the fact that I can automatically see that my leftover y is in the denominator. That's why I like it. However, you don't have to like it. You do what you need to do to get your answer. And then finally, the z's. We've got 4 z's in the numerator, 2 in the denominator. So that means when I simplify, I'm left with a z squared in my numerator. I'm sorry, that's a very odd looking z. But your answer is -7x to the power 5z squared over 8y. Right, and I saw that coming through quite a lot in the chat, so well done, guys. Just quickly, just because I can see Theo's answer here, if you want to write the exponent of 1 with the y, that's absolutely fine. We never have to write an exponent of 1, and we never have to write a coefficient of 1. But if you do, you will not be marked wrong. So it's absolutely fine if you put the exponent of 1 there. Okay. Right, so Princess, the y went to the bottom because, and again, this is how I like to think of exponents. If we go back to the technology tonight, me and technology. If I go back to the original question and I just look at the y's, I can see that I've got 7 y's in the numerator and 8 y's in the denominator. Now, this is going to be a bit long, so you don't have to write it down, but just bear with me. There are my 7 y's in the numerator, and there are 1, 2, 3, 4, 5, 6, 7. There are my 8 y's in the denominator. Now, I know that whenever I divide something by, I'm sorry, guys. I don't know.
It's
Whenever
working
I
perfectly
Oh, is it?
well.
Okay.
We can still see, even if it goes small and big, we can still see. So no worries.
Okay, right. So whenever I divide something by itself, I'm left with 1. So essentially they cancel out. 3 divided by 3 is 1. Negative 20 divided by negative 20 is 1. And this is why we can cross cancel. So the first y cancels with the first y, another y cancels with another, the third y's, the fourth y's, the fifth y's, the sixth y's, and the seventh y's. Now, when I get to the 8th y in the denominator, I still have a y there, but I've got no y's left in the numerator. And so that y that's left over must stay in the same position as where it originally came from. And so that's why that y is in the denominator. That's where it belongs. That's where it needs to stay. Okay, but writing it out like that can become a little bit tedious. And that's why we then have these exponent laws that we've spoken about previously. And like we said, they are on the website, so you're welcome to go and have a look at them.
Scarlett, you only need to just press that button that appears on your device and you can talk to us.
Hi, man.
Hi, Scarlett.
Bye.
I was just wondering, if you could minus them, like the x, y, and z, if you could minus, like, do you have to like divide it, or like the cross canceling?
Okay, so when you say minus, do you mean like what we were doing over here?
Yes.
Yeah, that's absolutely fine. So you are more than welcome to minus the exponents. Like I said, there's lots of different ways to do it. So if you're comfortable minusing the exponents, that's fine. The only thing is, like what happened with the y's, when we minus the exponents with the y, we ended up with a -1. But all you need to remember, that just means that it must then go to the denominator.
Okay.
Okay, but
so
that's
much.
absolutely fine. You do what makes sense to you. Like I say, I just don't like minusing for whatever reason.
Oh, because ma'am, at my school, like we get to minus it. So like,
and that is absolutely correct. There's lots of different ways you can do these sorts of questions. So you need to find what works for you and you do that. So if minusing works for you, that's what you do.
Okay, thank you so much.
Good, well done. All right, my sugar lumps.
What?
My sugar lumps. Okay, guys, that's fine. You don't have to enjoy sugar lumps. I call my children all sorts of different things. Okay.
My sugar lumps.
They get called sugar lumps. They get called chicken pies. When I'm annoyed with them, they get called other naughty things. But okay, guys, let us see. So with fractions, if you were here last week, we spoke about the fact that you can divide fractions. If you weren't, as long as a fraction is written over the same denominator, we can separate the numerator. So this can be separated into -18x cubed divided by -6x plus 6x divided by -6x. Because they were written over the same denominator, I can split the fraction. So I want you to try for me to simplify this whole thing. So simplify these fractions. And when you're done with that, we'll take a bit of a stretch and a brain break. Okay. So have a go at that. Keep putting your answers and keep asking me questions as you go.
Let's go, my people. You guys are doing great. You are doing great, guys.
And guys, remember, once you've simplified, check if there are like terms. There might not be, there might be, but double check those sorts of things.
Sanela, would you like to raise their hand and just try and explain how did you get that answer to teacher Sam and everyone? Would that be fine if you're feeling brave and wanting to share? Would really like to hear your voice.
Well, Sanela, that is commitment to maths.
No problem, Sanela. Thank you for joining us. That's very brave of you. Theo with an answer also. Anyone wanting to share, guys, you can definitely just raise your hand so you can explain to teacher Sam how did you get the answer, and to everyone.
Yeah, I'd love to hear from you guys if you're feeling brave, how we can go and simplify this. You can talk us through how we need to do this if you're feeling brave.
Yeah, Betsy. I'm putting my bet on you. Come and explain to us.
Careful of exponents, guys. Make sure that your exponents are correct.
Guys, if not, teachers, you can just hear teacher Sam only. If no one wants to answer, teacher Sam will just explain to us.
I'm going to pick on Theo. Theo, do you want to explain to us? If you don't want to, no pressure at all.
Betty saying he's not brave enough. Well, Betty, you've been talking to us now for quite some long time. Why are you not brave? We're here to help you. Remember that. So definitely at the end, you'll get it right. Either way. Theo says me too. Okay.
Okay, Kendra, I'm going to pick on you. Do you want to explain? No? Okay. Leto, do you want to explain?
Guys.
Well, if it makes you guys feel better, you are correct. So does that change the answer? Do you still want to not explain? That was horrible English. I apologize. Anyone feeling brave now? Now you're going to make me work for it. Okay. I'll see how it is. See how it is, guys. It's all right. Fine. We'll get there. We'll get there. Okay. No, Kendra is laughing at me now. I see how it goes. All right. Okay. Everyone's laughing at me. Jeez. Yes. All right. Let's go. First fraction. What do I get when I divide a negative by a negative? What should my sign be? Go, go, go.
Let's do this, guys. Let's see some answers on the chat. We're starting the SNV.
Well done.
Yes, my people.
SNV, guys. So negative divided by negative, positive. You don't have to write the positive there, but just remember it is going to be positive. Then we go on to the numbers. 18 divided by 6 is 3. And then x cubed divided by x, however you choose to do it, cross-canceling, subtracting the exponents, whatever you want, you should get an x squared. Then we go to the second term. Now, what we need to be careful of in the second term is that technically this plus sign goes with sort of that numerator. And so when I do my SNV, I've got a positive divided by a negative. Now, positive divided by a negative we know is a negative. 6 divided by 6 is 1. You don't have to write the 1 there, but you can. And we know that x divided by x, anytime I divide something by itself, I get 1. So actually all I have there is the minus 1. So because there's no variable there, I have to have that minus 1 there. If there was a variable there, then you wouldn't have to write the 1. But your answer here is 3x squared minus 1. Those aren't like terms, so I can't do anything more. That's my final answer.
Corrections. I see a lot of corrections supposed to happen because of the answers you gave on the chat. So you guys better do corrections. And if you don't realize where you went wrong, please do raise your hand or put it on the chat. And teacher Sam she's going to be happy to explain it to you. Okay. So if you don't see where your mistake is, please do put your hand up and she can explain to you guys. But well done for all of you for trying. I'm really impressed. Well, this is some spicy question.
Yeah, well done, guys. You're doing really nicely. Keep going. And like we said, like get it wrong, figure out where you're going wrong, ask us the questions that you can learn. Right, if you've done all your corrections, get up, take a stretch, get the blood flowing. Oh, maybe Kendra needs to lead us in a stretch.
Oh, yes, Kendra. You're my appointed one. Lead us on the stretch. Let's go, guys. Ooh, it feels so good to stretch. I see that, Kendra. Ooh, Lisedi, I see you over there.
Nice, guys. Oh,
it feels so good.
I'm sitting on the floor tonight, and I think this is now where I live. This is it.
No.
Thought it might be comfortable. I was wrong.
You'll find your spot soon. Give it a little bit of time.
Yeah.
All
right.
I think I've answers already, my people.
Yeah.
Fire.
So this is a little bit different to what we have done in the last 2 lessons. You've got some products going on here. So we've got 5 times 3 equals 51. Now we know that in the real world, 5 times 3 is not 51, but you need to start looking for a pattern in these answers over here. So I'm seeing some great answers. Keep going. And if anyone is feeling brave, can we put up a hand, or even in the chat? I will accept in the chat. Can we explain what we think the pattern is that's happening here? Oh, there we go. KM, do you wanna raise your hand and explain it to all of us, or are we leaving it in the chat? I tried. Okay, so exactly. The little pattern that we have going on here is that whatever the product is, we just swap it. So we know that 5 times 3 is 15. And if I swap those numbers, I get 51. 5 times 5 is 25. But if I swap those numbers, I get 52. And so in the last one, when we've got 5 times 6, which is 30, if I swap those numbers, I get 3 or 0, 3. All righty.
I just love the joke there. I had a hand that could count her own eggs. She was a mathematician. Guys, that's so funny.
Plenty more, so get ready, everyone. Alrighty, well done, guys. Well done on seeing that pattern. That's really good. And so when you actually start to do things like number patterns in maths, your brains are already starting to be trained at looking for patterns. Well done. Oh, golly, Miss Molly. Okay, are we ready? Yes. Wonderful. I like to see a yes. So let's have a look-see here. We've got 2x times x minus 1 plus 3 times 2x plus 3. So remember, identify your terms. I'll help you there to start off with. Term 1, term 2. I know that because this plus is separating my terms. And once I do that, I now want to simplify each of my terms. Now to simplify the first term, I have to multiply. Sorry, that was a very weird arrow. The 2x into the bracket. And to simplify my second term, I need to multiply the 3 into the bracket to both of those terms. Right, so I'm going to give you 2 minutes. I'd like you to try and simplify the whole expression for me. So multiply, and then check and see if you've got any like terms that you can add or subtract. And ask me questions as you go, pop answers in the chat as you go. Let's see where we're at.
Let's do this, my people. Let's do it. You guys are doing great. Keep going. Remember, trying is always the best. You need to try first.
Right, and guys, just to help you a little bit so that you know what you're multiplying, I'm just going to write down the products that you need to be looking for here, because what we need to be careful of here are those exponents again. Horrible square, I apologize, but it's all right. So if we're going to look at the first term, which is 2x times x minus 1, then what we need to remember is that what we're multiplying is 2x times x, and then 2x times negative 1. If we look at the fact that, or if we look at what we're multiplying in term 2 is then 3 times 2x plus 3. So we're multiplying 3 times 2x and 3 times 3. So just be careful when multiplying that you're multiplying the correct values and that you're remembering your exponents as well in that multiplication step. Okay. Right, so if we start checking, if you're not finished, don't stress, you can finish off, otherwise you can sort of mark as we go along. If we start to multiply, so I've sort of listed the multiplications that you need to do for you. If we've got 2x times x, we end up with 2x squared, and 2x times negative 1 is negative 2x. So that's what I get for my first term. And then for my second term, 2x times 3 is 6x, and 3 times 3 we know is 9. So I've got plus 6x plus 9. And then I go and check if I have like terms. So I can see I've got an x squared term. I don't have any other x squared terms, so that's it. No more like terms in that group. I've got 2x terms, so I'm going to be able to add those two together. And then I've got my 9. Can anyone remember what we call a term where there's just a number? Nice, guys. Well done. Exactly. A constant.
Yes, my people.
All right. So now we add our like terms. The 2x squared is just 2x squared. Minus 2x plus 6x is plus 4x. And then we've got our plus 9. No more like terms. So I'm done with that. All right, guys. Well done. So I saw that sort of popping up a few times in the chat. So well done to those of you who posted that as your answer. If you didn't get that as your answer, please double check where you went wrong and ask if you have any questions. Okay, otherwise I'm going to scroll over to question 2. Right, I'm going to ask you to try this by yourselves. So remember, we want to find our terms, and remember, term is only separated by a plus or a minus sign. So when looking or identifying your terms, just bear that in mind. And then I want that simplified. So have a go by yourselves, give it a try, post your answer in the chat, or if you're feeling brave, put up your hand, and then we'll have a look. Alrighty, so do you have a question? No? Maybe I was hearing things.
Mehdi, you can click on, there we go. Mehdi, are you here?
Yes, ma'am.
Evening.
Ma'am, I'm sorry, but there's load shedding at my area, so I have to go. But I'll see you on Wednesday.
Okay,
That's
no problem.
Yeah.
No,
Bye,
sorry,
ma'am.
Linda, you go.
No, it's fine. Bye, Mehdi. It's okay. We have it recorded, okay? No worries. Thanks for letting us know, though.
Yeah, thank you. Okay, guys, so if you are struggling to identify your terms, remember it's just the plus and the minus sign that separate them. So this whole division there is term 1. The 4x squared is term 2, and then the minus 3x squared divided by x is term 3. So hopefully that helps you a little bit if you're struggling to identify your terms. And if you want to, you are always welcome to rewrite something with a division sign as a fraction. For some people, it's a little bit easier to work with fractions than it written out as a division. Okay, now when we want to go and simplify this, we're going to use S and V for the fractions. So if we start with this first fraction, of positive divided by a positive is still going to be a positive, so nothing's going to change there. 12 divided by 3 is 4, and then the x squared, well, there's no x's in the denominator, so it just stays x squared. Then we've got the plus 4x squared. And then in my last fraction, I've got a negative divided by a positive, which is a negative. 3, and remember this x has a coefficient of 1, so 3 divided by 1, which is actually just 3, and x squared divided by x, however you choose to do that, you end up with x, so negative 3x. Then we collect our like terms, so I've got x squared terms, and then I've got the x term. And so when I add and subtract all of those like terms, 4x squared plus 4x squared is 8x squared minus 3x. I can't add the 8x squared and the 3x because they are not, or subtract the 3x because they are not like terms, right? So that's really important. They're not like terms, so I can't actually do anything further than that. Right, so if you got that right, well done. If you didn't get that right, well done. Do your corrections and then ask me if you have a question or if you're confused about anything that we've done here.
Kendre, how was it? Did you get it right? Lisedi, did you get this question right? Ooh, I see you, Kendre. Kendre got it right. Lisedi, how was it? Did you manage? Yes, I am talking to you, Lisedi. I see those eyes. Guys, if you don't understand, like Teacher Sam said, it will be nice to raise your hand and tell us where did you go wrong. And if you did do it wrong, however, and you do understand where you went wrong, that's perfect. Oh, Lisedi, okay, cool. That's what we want to hear. Anyone else? Or should Teacher Sam continue? Carlton, what about you? I see you writing there. Is everything fine? Okay, Carlton is also fine. Princess, Likue, KM, are you guys okay? Theo says, I understand too. That's great. This is what we want to hear. Well done, guys. This is some spicy question. I like to say spicy questions.
Okay.
They are kind of hard.
Yeah. And guys, it's not necessarily to try and trick you. It's more so that you can see the different types of things that you can encounter. And also a lot of these questions that we're doing are questions where the same mistakes are being made. And so if we can practice these sorts of questions, then hopefully we can avoid the mistakes that are often made. All right. So by no means do you need to get it on the first try, but as long as you keep trying, you will eventually become more comfortable with the stuff. All righty. The Sadie, I completely agree with you. I always write it as a fraction. I don't like the division. I think it's much easier when you write it as a fraction. And so I would definitely go with that. But obviously, guys, if you are happy with the division sign, that's also absolutely fine. You must do what makes sense for you. Okay. All right, so let's have a look at this third one. Now, if you were with us last week, we did deal with something similar, but let's have a look at this again. So identify our terms, that's the first step. So this minus sign is going to separate my terms. So my terms here are actually the 2 times the bracket times the y, and then the negative x times 4xy. So to just help you a little bit, what I'm going to do is I'm going to write out what multiplications need to happen here, just because I think it's going to help. So if we look at term 1, oh, she's testing me today. If we look at term 1, I have got 2 times the bracket x squared plus 3y times y. And then if I look over at term 2, I have got negative x times 4xy. So those are the 2 multiplications that need to happen. Now for term 1, what we can do is we can actually go and multiply the 2 and the y first. The reason being is because it doesn't actually matter what order I multiply things in. 2 times 3 times 1 is the same thing as 3 times 2 times 1, which is the same thing as 1 times 2 times 3. Any order I put those numbers, when I multiply them, I get 6. So by me multiplying the 2 and the y together first, it's not changing anything. So this can be written as 2y times the bracket x squared plus 3y. And the reason that's useful to me is now because when I go and multiply into my bracket, I'm just multiplying one thing in. Rather than if I hadn't changed it to 2y times the bracket, I would be dealing with the situation of needing to multiply the 2 in. And then once I've done that, multiplying the y in, which is a little bit complicated. All right, so I've sort of started you off. I'd like you to carry on and simplify this expression for me. So I've told you what needs to be multiplied. I want you to go and try that for me. And then if you want, you're welcome to put a hand up if you want to explain or put your answers in the chat. But let's have a see and try this.
And these spicy questions, guys, is always good that we make mistakes here, like this at your school when you have a test or, you know, whatever it may be, even if it's an exam, you won't do the same mistake. So yeah, feel free to make as much mistakes as you want so we can correct you. Because at school, you can't make the same mistake. So I like what teacher Sam is doing, teaching us all the tricky ones that they can put on your exam.
So guys, for example, this one, what often happens is they'll give you a situation where you've got 2 things being multiplied into your bracket, like what's happening in term 1. And often we just panic and we think, oh my gosh, there's too many things happening, I can't do it. But now we know how to deal with it. We put the thing at the front and at the end together, and then we can deal with that separately. Alrighty. Okay, so guys, if we have a look at this multiplication, 2y times x squared is 2x squared y. If you wrote it as 2y x squared, that's not wrong, but we try and write our letters or our variables in alphabetical order. So that's why I put the x squared first and then the y. Then we've got 2y times 3y. So SNV, positive times a positive is a positive. 2 times 3 is 6. Y times y is y squared. And then for term 2, I've got a negative times a positive, which is a negative. There is a coefficient of 1 there, so 1 times 4 is 4. X times x is x squared, and then I've got my y. There's no y to multiply with it, so it's just y. So when I write out my expression with all of those things together, I've got 2x squared y plus 6y squared minus 4x squared y. Now I can gather my like terms. So I've got the x squared y terms, and then I've got the y squared term. So when I add these together, 2x squared y minus 4x squared y is minus 2x squared y plus 6y squared. And that is my simplified answer. I can't do anything more than that because they're not like terms, so I can't add or subtract them. So that is what it is. Again, if your variables are in a different order, so you have minus 2yx squared plus 6y squared, or even if your terms are the other way around, so let's say you've got the 6y squared first and then the minus 2x squared y, all of those are absolutely fine. We just try and write it like what I have over here with my variables in alphabetical order. But yx squared is the same thing as x squared y, but try and put it in alphabetical order. It'll just help you in the long run as we get into more complex algebra in grade 9, grade 10, etc., etc. Okay, guys, so that's where we're going to stop because it is almost 7 o'clock and you do indeed have a poll.